Hello 7th graders, this is Mrs. Trombley with lesson 6.5, the surface area of cones. If you're following along in your book, you should be on pages 278 and 279. Get your calculator, please. Make sure you have something to write with. Alright, so the surface area of a cone is the sum of the areas of the base and the lateral surface. So we know right now, base, that means the bottom. Lateral surface is kind of like the side. So there's really only two parts to this. There's a bottom and there's a lateral surface. The formula you're going to use to calculate it is right here. If you have a highlighter and you want to highlight that, it's going to be very special and important to you. So to find the surface area of this, we take pi times the radius squared. Maybe you recognize that. That's the formula for the area of a circle. And if you look at the net of a cone, there's a circle. So that's where that comes from. In order to calculate the area of this cone part, it actually looks like this when it's opened up. And the formula to calculate this surface is pi times the radius times, and they call it L. It actually means the slant height. I would like to call it S, but the book doesn't, so I don't want to, mess you up. So we're going to call it L. All right. So the slant height L is a distance from the vertex of a cone to any point on the edge of its base. Meaning vertex is kind of like where these lines meet. And here's the edge of the circle. So this can be slant height right here. You could also consider that the slant height. So that's what all this stuff means. The radius is still the distance halfway across the circle. Sometimes we will trick you and give you the diameter. Make sure if you get the diameter all the way across, you divide it by 2 to find the radius. Alright, so you've already seen this all opened up in class. I won't humor you with it. Let's move on to some examples here. In example number 1, I give you a cone. And luck has it that I give you the radius, and I give you the slant height, and I give you the formula. Now, I'm not going to give you the answer. I do want you to work for that one. So, same as usual. Let's write down our formula. It is pi, scooch up a little bit, times the radius squared plus pi times the radius times the slant height, or we'll call it L. So just like before, let's identify what our R is, our radius is, and what the slant height is. So in looking at this, we see here's a circle, halfway across is 1, and the slant height is 3. Now, show me what you're going to type into your calculator. We're going to use 3.14 for pi like normal. So 3.14, we're supposed to multiply that by the radius twice, so times 1 times 1. To that, we're supposed to add pi again and multiply that by the radius and the slant height. So type it in. Do you have it? All right, the surface area, if you did it right, should equal 12.56. The unit is meters, and we're still measuring area. It is still squared. Don't forget that little 2. All right, here's another one, example 2. Here's another cone. It fell over. Poor thing. Party clown gone bad. All right, so same formula. It is pi times the radius squared. That gives me the area of the circle part. To get the lateral surface, sounds so technical, it's pi times the radius times the slant height. Our radius halfway across the circle, didn't even try to trick you this time, it's 2. And the slant height, even though it's on its side, the 6 is not part of the circle. That makes it the slant height. It's 6. Plug it in. 3.14 times the radius squared, so twice, plus 3.14 times the radius times the slant height. Plug it all in. I'll give you a moment. Do it, do it. What did you get? Was it 50.24 feet squared? If it was, give yourself a pat on the back. If not, give yourself a smack in the face. Just kidding. All right, example number 3. Parents are going to be upset with that one. It's just a joke. Nobody hit anybody. All right, real life application. Party clown time. You design a party hat. You attach a 7-inch piece of elastic along the diameter. How much paper do you need to make the hat? All right, so here's our little hat. This right here, I'm hoping you're seeing that that's the slant height that's given. And you might be thinking, well, hey, there's no radius there. What am I supposed to do? Well, I did tell you that you attached a 7-inch piece of elastic along the diameter. So that actually means, if we kind of draw this out here, the bottom of the party hat, this is your elastic, and it's 7 all the way across, right? We need a radius. So if you're given 7 as a diameter, to find the radius, you take 7 divided by 2, so our radius is 3.5. Now, you may just have already written this formula down, but you don't need the whole thing for this problem. This is one of those tricky ones, like the mushy peas and the cat food example. I know, you're probably really hungry now. Here we go. I just want to know how much paper you need. Most people don't put paper on the bottom of the hat. They have a little string and it goes on your head. So really all we need is the surface area of the lateral face. Now in this formula, again, we recognize at the beginning that this pi r squared, that's how we find the area of the circle. We don't need the circle. So forget about that. All we have to do to find the paper is pi times the radius times the slant height. So pi, 3.14. The radius we already figured out. It's 3.5 because the diameter is 7. 7 divided by 2, 3.5. And the slant height of this one is 5 inches. When you multiply it all out, the amount of paper you would need is, do you have it? Do you know it? It is 54.95 inches squared, and you are done.
Record time.
Woo!